Hi guys, let's talk about second order recursive relations today. So, in second order recursive relations, we generally use this formula. A of n equals R of A of the number before 1 and plus a coefficient and the two numbers before, whatever that number was. Okay? For all n greater or equal to 2. Okay, as we do the example, you will see how we use this formula. Okay, and there's two cases. So if x1 equals to x1 does not equal to x2, we use this formula. If x1 equals to x2, then we use this second formula. Okay, so let's have a look at an example to see how this actually works. Say we are given a of n equals 5a(n minus 1) minus 6a(n minus 2) for n greater or equal to 2. Okay, so first step, we see that it matches the condition n greater or equal to 2. It looks like this formula over here, 5a(n minus 1) and then it just has a minus sign. So second step, what we do is we a of n, right? We assume that as x squared, okay? And then a of n minus 1, we assume it as x. And minus 6, we just leave it at like that, okay? So now you can see it kind of looks like a quadratic, okay? So that's our next step. We got to solve this quadratic. So we subtract minus 5x, both sides, add 6, both sides, okay? If we solve for the x value, we get minus 3 and minus 2. Okay, so our x1, we could assume as x1 is going to be 3 and x2 is going to be 2. Okay, since both of them are different. Okay, since both of them are different and x1 is not equal to x2, we further go on to use this formula. Okay, so let's try using that formula. So next step, what we're gonna do is we're gonna say a of n equals c1 x1 to the n power. Again, that's what is over here, and then we're gonna add that to c2 x2 to the n power. Okay, and then what we do is we kind of go and look back at the problem, and we see if a of n equals to what they also have given us two more things in the question. Actually, they've given us that a of 0. Remember, only if we are given something like this is when it becomes easy to solve. But they have to give us two initial conditions: what a of 0 is and what a of 1 is. Then only can we use these formulas. Okay, so a of 0 equals -3 and a of 1 equals -2. Okay, so now what we do is we kind of go and look back at this problem, and we say if n equals to 0, right? Then a of 0 equals to so that's what we got to figure out. Okay, a of 0 is equal to, well, actually we know that it equals to -3. Okay, so we kind of go further and we say a of 0 equals c1 x1 to what power? To the 0 power. Okay, plus c2 x2 to what power? Again, it's to the power of n, right? And n in our case is 0. Okay, so a of 0 we know is -3 equals c1, because at times x1 to the 0, that's just going to be 1, plus c2, which is just c2, and x2 to the power of 0 is just going to be 1. So our answer is going to be -3 equals C1 plus C2. So this is our first equation. Okay. Now you're going to see if you've done linear equations, substitution, elimination, trying to solve for the two values, C1 and C2. That's what we're going to do in further steps. So now we also have one more A1, right, that we have to take care of. So let's say A1 equals to C1 x1 to the x1 to first power, right? Because it's to the power of n, plus C2 x2 to the power of n, which is 1. Okay? Now A1 we figured out it was here, as you can see, it's -2. They've given us that it is -2. -2 equals C1 times x1. What is x1 again? X1, well, let's first, so because now we don't have to the 0 power, right? So we have to the first power. So x1 we figured out here, it is 3. Okay, so times 3 plus C2, we're just going to say C2 times x2. We figured out it was 2. Okay, so our second equation is going to be 3C1 plus 2C2. Alrighty, we've gotten our two equations. Now we got to solve for C1 and C2. So again, as I was saying, here you're solving using the elimination process could help us find C1 and C2. So let's do elimination. So negative, we could do 3 negative -3 equals C1. Let's do C1 plus C2 so that we do it more the conventional style. C1 plus C2 equals -3, and 3C1 plus 2C2 equals -2. Okay, I'm kind of looking at these two coefficients and I'm thinking, let's multiply this by 3. Okay, so what that's going to give us is 3C1 plus 3C2 equals -9. Okay, 3C1 plus 2C2, because we didn't do anything to the bottom equation. Now what we could do, we could multiply the bottom equation by minus. So what that does is just changes the sign. Now you can see it has plus 3C1 and minus 3 C1, right? So cross that out. Okay, 3 minus 2 is just going to give us 1 C2. Okay, -9 plus 2. Okay, because we changed the sign on 2, right? So that's going to give us -7. So our C2 value that we figured out was -7. Now we don't need to do the elimination process again. What we could do is use this first equation, plug C2 into it. So C1 minus 7 equals -3. Okay, so we add 7 to both sides, and what we get is C1 equals 4. Great, so we found out what C1 and C2 is. Okay, now it's time to write down our final non-recursive uh, solution. Okay, so what it's going to be is, it's recursive, by the way. It is a recursive solution. So it's going to be it's going to resemble this first equation over here. Okay, I'm going to zoom out so that you can have a look at it. So, oh, that's a bit too zooming out. So I'm just going to go back. Okay, so A of n is going to equal to what our C1 was. Okay, so it's going to resemble this equation actually, this one over here. So C1 we figured out was 4. Okay, times our x1 value. What is our x1 value? Our x1 value is 3. Okay, because we figured that out over here. So 3 to the n power. Okay, plus our C2 value. What is our C2 value? Our C2 value is -7 over here, as you can see. So that it's like now we're putting the puzzle together. -7. Now we multiplied this by I'm just putting the bracket so that we know that bracket is with -7. And now our C2, or I mean our X2 value is 2. Okay, so it's going to be 2 to the power of n. Okay, so that is our second order recursive relation. Okay, guys, I hope you gain a firm understanding of this. If you do have any questions, please leave them down in the comment section below. And yeah, please like, share, and subscribe to the video. It really helps. Thank you so much.